Alrighty, gang. We're still talking about arrays. I think we're getting close to being done with the chapter. We need to talk about multi-dimensional arrays. We're going to talk about two-dimensional arrays. Then we may play with one-dimensional arrays just a little bit more. Arrays are awfully important, so I don't mind spending the extra time on it. But hopefully this will be the end of that chapter. Let's see where we are. Had to switch machines, so let's see. I think this is the page number we're at. Okay, so we already know what a one-dimensional array is. One-dimensional array just means in a line, right? You know, a single series of numbers. Like here, you know, test scores, 75, 82, 100, 90, 92, right? That's a one-dimensional array. A two-dimensional array is a grid, a matrix, right? Two-dimensional array. If we Google it up and find a picture of it, right, it's just a grid. You have columns and you have rows. And so that element, you know, is row 0, column 0. And typically you say that the row is first and that the column is second when we're specifying its column. So that's 0, 0. That's 0, 1. That's 0, 2. Now, can you do it the other way? Could you call the, the rows, the second number and the columns of it? Yeah, but by tradition, the first number in your subscript is the row. The second one is the column. So this value right here would be row 3, column 1. So that would be item subscript 3, 1. You know, an Excel spreadsheet is a good representation of an array. You can have more than two-dimensional arrays, but our minds kind of break, once you get like past three-dimensional arrays. Three-dimensional array could represent, like a game, a 3D game, and your position of your character on that 3D space or whatever. But we're going to stick with two-dimensional arrays pretty much. So a two-dimensional array requires multiple subscripts because you have to be able to specify which row and which column. So a rectangular array can also be called a matrix or a table. And if you've taken higher math classes, you may have done, matrix multiplications or whatever, matrix transforms. I could assign y'all a program like that. I probably won't. So here we have sales item 00, 01, 02, 03, 10, 11, 12, 13. 20, 22, 21, 23. So this is a 3 by 4 array, meaning that it has 12 elements. To figure out the number of elements in it, you multiply the rows by the columns. Now you'll see after a while that I believe you can create what are called ragged arrays, where each row can have a different number of columns. And that's really not my key interest here. My key interest is when each row has the same number of columns, so it's a perfect rectangle. So when you initialize an array, you can use this silly syntax, right? This is the first row. This is the second row. This is the third row. I'm going to copy this and paste it in a notepad so we can play with it a little bit more. Make the text bigger. So when we're using an initializer, we always start our initializer with a curly brace. But in this language, we can consider a two-dimensional array an array of arrays. So each item in our array is another array. And maybe you've done nested loops in Python. Very similar idea. So the way we declare a two-dimensional array, if we're going to use an initializer, is we give the data type, and then after the data type, we use the braces, but we put a comma there to indicate that it's a two-dimensional array. If it was going to be a three-dimensional array, we'd put 2 commas there, kind of like, implying a X and a Y and a Z, something like that. But we're playing with a two-dimensional array. And so these are our sales. Apparently we have 4 salesmen and 3 periods, or we have 3 salesmen and 4 periods. Now, are we usually going to initialize our array like that in real life? No, we would probably just allocate an array of a certain length, and then our program would fill in that data. You know, read from a file, or ask the user for input, or something. Create random numbers, whatever we wanted to do. So here's one where the row number represents which floor we're on. And then we're charging rent based on whether the apartment has 0 bedrooms. Kind of an odd idea, but why not? Or 1 bedroom or 2 bedroom. So we could say I want to live in a penthouse, right? The top floor. So a 0 bedroom place costs $1,000 a month. A 1 bedroom place costs $1,250. A 2 bedroom place costs $1,600. And this here would be a declaration for the same kind of data, right? Notice that this is not part of the declaration, it's implied, right? We have 4 rows, so we have floors 0, 1, 2, and 3. And then these columns are also implied, right? This is element 0, column 1, column 2. And you could make some parallel arrays, right, that matched, you know, the column 0 to the word 0 bedrooms, and the column 1 to the string 1 bedroom, and the column 2 to 2 bedrooms, something like that. I'm going to skip this one. We pretty much have the idea. Well, I guess I'm not skipping it if I'm talking about it. We ask the user which floor. We store that in a variable called floor. We ask the user the number of bedrooms they want. We store that in a variable called bedrooms. And then we access that element of the array, the rents array, using a syntax, subscript, floor, comma, bedrooms, which row we're on and which column we're on. So if they said floor 2, bedrooms 1, well, this would be 0, 1, 2, right? We're still counting as 0, so that would be row 2, and 0, 1, that would be column 1 right there. So if we typed in, I've already forgotten my numbers, 2, 1, then it will print out 676. A 3-dimensional array. Alrighty. Are you really going to want to declare something like this? It's an array of 2-dimensional arrays, where each array is an array of single-dimensional arrays. Alright, my brain kind of hurts, but you could do that, you know, kind of like XYZ coordinates, you know. That's about enough of that. Read up on them. And then a jagged array. A jagged array is one where each row has a different number of items. Right? This row has 2 items. This one looks like it has about 6. This one looks like it has about 5. And that one's kind of a mess, you know, but it's still processable. You just have to figure out how many columns are in each row when you're printing it out or you're adding up your numbers or whatever. Alright, so let's play with some arrays. So I'm going to go ahead and start good old Visual Studio. Guess what? Since I'm on a different machine, I'm using a different version of Visual Studio. I'm using the one you are. It's 2017. So I'm going to make a new project. It's going to be a C# console app. I'm just kind of peeking around here. Alright. Getting started. I want a console app. Visual C# getting started. Maybe yours looks a little bit different, but you've been doing this the whole time. What lecture are we on? Good question. We're on lecture element O. We're on lecture O. Okay, so I'm going to call this one lecture O. Yeah, access to the path, administrator sources denied. So I have to go back. You don't have to do this, but I do. I have to pick a different directory to store my stuff in. So I'm going to choose browse. I'm just going to store stuff. PC, desktop. Good enough, huh? Alrighty. Try once more. Lecture O. All right, so first thing we're going to do is we're going to follow their little syntax for using an initializer list. So I'm going to create a 2D array called TDA1, two-dimensional array 1. But it's going to be 2 dimensions, so I'm going to put my square braces there, just like I was declaring any other array. But I'm going to put a comma there to indicate that we're going to be able to specify, you know, an X and a Y, a row and a column. All right, and then I'm going to put in those values, right? So it's an array of arrays. That's why I'm doing it in this kind of weird syntax. Not exactly what the book shows, but it's kind of close. So the first row are going to be the values, I don't know, 987. And then a comma outside of that. Now here's our second array in it. 6, 5, 4. And then outside the curly brace, another comma. And now we're entering our third array. Now that's really enough, right? We have 2 rows, 3 columns. That'll be enough to play with. Well, I'm just going to make a little comment to myself here. Oh, and we need a semicolon because that's the end of our declaration. We have 2 rows, 3 columns here. We could ask for the number of rows and the number of columns, and it would tell us. That's actually the right way to do it. So, int rows is equal to TDA1 dot get length. In this case, the length of the array, and I seem to have made a mistake here. Oh, 0. That means on the first dimension, the number of rows. And then, when we want to, we can get the length of an extra array, the length of the columns. So int calls is equal to TDA dot get length subscript 1. So this is a number of rows, this is a number of columns. Now you have to do a different solution if you're going to use ragged arrays. I may not even give any examples of ragged arrays. I just want you to have in mind, I'll repeat it, that a ragged array is one where each column can be of a different length, right? You have a certain number of rows, but every column might have different length. One student may have 10 test scores, and the other may have only 8. Alrighty. So now we could use a loop to print this out. Print out 987654, or we could add up all the numbers in the loop, something like that. Hi. Ready. Okay. So, int r, I'm going to use the variable r to represent my row, is equal to 0. We're going to count r is less than num rows, r++. And we're going to do the same thing for the columns. For int c is equal to 0, c is less than, oh, I didn't make it num rows, I just called it rows. So change that to rows. And then c is less than calls, c++. Now we already had the for each syntax, and we may try to figure out how to use for each in order to do this. We'll see. All right, and then I'm going to print this element out. Console.write. The 0th element, or yeah, you know, a placeholder for 0, followed by a space. Why not? And here's where we represent our call to the array. We use a subscript, but we're going to use 2 values in our subscript. TDA1 subscript r, c. Let's make the text a little bit bigger. Okay. All right, that makes sense? That's how we're getting that value out. And we're going to wind up doing this loop a lot. So we may copy and paste it when we're done with it, you know. Or we could put it in a function. That would be the better thing to do. All right, and so the reason we didn't use right line is because we wanted to print an entire row, right? These are the columns. So we're going to print column 0, column 1, column 2, comma 3, and then we're going to print, you know, then we're going to go to the next line, like hitting enter on our keyboard. So console.writeLine. There, that'll get us back to the beginning so that we're ready to print out the next line. You know what, it's my belief, I could be wrong, that dark text on a white background is easier to see when you're watching a video. I could be horribly wrong, but I'm going to pause the recording and change that. Actually, I don't even have to do that. I'm going to edit. I'm going to go to Tools, Options, Fonts and Colors. Oh wait, I just left it. General, Color Theme, Light. And that didn't, yeah, there we go. Maybe that's worse. All right. Anyways, this is our code. Pause it if you need it. Let's run it. Let's see if it works. But I'm going to add a console.read key at the very bottom. All right, and there's our itty bitty array 987654, just like we declared it. All right, easy mistakes to make are where to put this. This needs to be outside the inner loop. This is the inner loop, right? It can help if you label with comments your loops. This is inner loop. This is your outer loop. Maybe that just clutters it up for you. And then, of course, down here, way down there, is the end of main. Oh, look at all that. Not used to having, I've been using a different version than you. Okay. Alrighty. And so this is the end of main. And yeah, that probably just makes it harder to read. I'm going to delete those comments now, but if you like them, put them in. Alright, like I said, we're going to wind up using this over and over and over. Except we're probably going to wind up changing our array name. So let's create a different array. Let's create an array of fixed length. So rather than using an initializer list, all right, so, you know, a TDA1 is really kind of a lame name. I'm just going to call this one array 2. Now I wish I'd chosen a better name for that. So anyways, this is also going to be an array of ints. Int, same syntax, right? When you declare an array in this language, you put the square braces after the type. But if it's a 2D array, you put a comma in there. And I'm going to call it array 2, just because it's a new array. I could reuse that name, but let's not. Is equal to an integer array that is 5 by 6. Right? 5 rows, 6 columns, something like that. And I forgot the keyword new. We're making a new array. So there we go. Int that array is equal to new int, specifying the size. And by the way, if you were going to make a 1D array, it would be similar syntax. Int like that. A1 is equal to new int right 10. That would make an array that was of 10 length for a one-dimensional array. Right. That's just as a reminder. 1D array. All right. Maybe we ought to put some random numbers in here. I don't know. Random numbers are kind of silly, but they're also kind of cool. So let's make a random number object and fill that 2D array with random numbers. So our random number object, our random R&D equals new random. Now let's use this very same loop. You know what, we'd probably better type it again because otherwise I'm going to have you enter it and then I'm going to be deleting it. And alrighty. So let's do this. We're going to tidy it up a little bit so that we don't have to have the number of rows in advance. Right? I don't want to have to recalculate these every time I make a print array or something to the sort. But we're not printing this time. We're going to be filling with random numbers. So for int r, again, why not r, equals 0, r is less than, and our array name is array2, so we're going to use array2.getLength. Array2.getLength. And inside here, we're going to specify that we want the length of the first, right, the number of rows. 0 means the number of rows. So after my get length, parentheses and parentheses, r++. Now this syntax is going to look a little bit weird because I'm going to try to get the length of the current row. Let's see if I can do that. For parentheses int c is equal to 0. I'm going to go on to the next line because, you know, my space is limited. C is less than array2 subscript r in subscript dot. And that didn't work. That didn't give me the length of it. I was hoping to do something cool. I guess I won't do something cool, and I'll just do C is less than array2 dot get length. But instead of 0, which means the number of rows, I'm going to use 1, the number of columns. C++. Alrighty. Now we're going to, pardon me, sorry for the dings. Now we're going to assign every element in there a number. So, array2 subscript r comma c is equal to, and we can make it some random number, or we could just fill it with zeros, or we could fill it with r times c, right? Whatever. We'll do the random numbers in a minute. I just want to see some values, right? The row number times the column number. 0 times 0, 0 times 1, 1 times 2, whatever. Now I'm going to need to print that. That is going to be so similar to this that I am going to copy and paste. Probably better would be to make a method that did it. I'm going to copy all that. And then I'm going to paste it, but instead of assigning a value here, I'm going to print it out. So console.writeLine. This is on the second, the copy of it. Placeholder 0, comma, and then my value, which is array2 subscript r comma c. But we don't want to do a write line. Didn't I make the same mistake last time? When we're printing out a row, we only want to use write because we don't want to go to the next line until we're done printing out all the columns. And so inside the inner loop, we use write. Outside the inner loop, we use write line. All right, so let me zoom back up here and try to get both pieces of code on the screen so you can pause if you need to and type it in. All right, this is the one where we assign the values, and that's the one where we print them out. I guess I should test it first before I sit there and wait for y'all to type it in. All right, that looks pretty lame. That's really poorly formatted there. So what we're going to do is we're going to specify a minimum width for each one, right? So we're going to have to modify our placeholder. Here's our placeholder, right? This means parameter 0, but if we put as comma, oh, changes are not allowed. All right, let's stop running. Hit that little red thing, or however you like to stop moving. Anyways, after the placeholder number, if you put comma 4, that means 4 spaces wide, right? Every number that we're printing out is going to be formatted to be 4 spaces wide. All right, and there we go. Right, and so since our values were row times column, then everything in row 0 is going to be 0, everything in row 1 is going to be 1, and this is row 5, column 4, so 5 times 4 is 20. That works. All right, there's all of our code. All right, guys, I wish this syntax was a little bit shorter. I wish I could use nested for each loops, but I haven't figured out how to do that. I need to look at the book again, but I don't think the book shows how to do it either. As a reminder, you can use for each to rip through an array really quickly, right? So if I declare a one-dimensional array, right, I don't care what it's going to be, an array of strings. String, you know, colors is equal to, and then I'm going to make, you know, red, blue, and green in there. Then if I want to print those out, right, for each, parentheses, string s in colors, print it out. Console.writeLine s. You know, we can make it fancy or whatever, but that's enough to demonstrate the idea. If we want to make it slightly more generic, we can replace string with var so that no matter what type of data was stored in colors, this would work, right? If it was a two-dimensional array of ints, that'd work. If it, excuse me, a one-dimensional. If it was a one-dimensional array of floats, it would work. One-dimensional array of strings, because var just means, you know, let the compiler pick the variable type. All right. Are we tired of two-dimensional arrays yet? Well, I kind of am. But we've shown how to print them out. Let's write something that'll sum the two-dimensional array. Now, if we're going to sum the two-dimensional array, we could actually just use a for each loop for every int in our two-dimensional array. Why not do that? And then let's print out the values as we sum them. So int sum is equal to 0. You always initialize your accumulator before you go. And then for each, parentheses, int I var v, I like v for value, in our array, in array 2. Let's add that to our sum. Sum plus equals v. And let's print out v, just to see what it is. Console.writeLine. We're going to print out the number and then our sum, just so that we can see that number increasing. So I'm going to need 2 placeholders because I want to print 2 values, the sum and v. So there's placeholder 0, whoops, curly braces, and then placeholder 1. So we're going to print out v, comma, and then the sum. And there we go. That's really enough to do adding all the values of a two-dimensional array. Now you could do it the same way we did it here. We could use a, you know, a nested loop, where we go through the rows and we go through the columns. But since C# does have this cute little for each function, to make it a little bit easier, I'm going to go ahead and do it that way. All right, and there we go. You see that it's not printing it out as a matrix, but that's useless frippery for just adding numbers. So if we can do it with a single loop rather than a nested loop to add our numbers up, I think that's a better solution. Easier. Let's add some comments here saying what we have done here. This is sum the values in a 2D array. Actually, it could be of any size. The same syntax would work if it was a 10-dimensional array, right? It's still going to go every int, every variable in that array. But I'm just going to say sum the values in a 2D array. Maybe I should change it to multi-dimensional array, whatever. And then here I'm going to add a comment that this is a for each demonstration on a 1D array. Then in a minute I'm going to scroll up and add a comment saying that I'm printing out, the 2D arrays. So up here, print our 2D array. Now some of y'all assign the values in the two-dimensional array and you printed them at the same time. That's okay. All that means is that you calculated the value there and then you printed it out. So my comments won't match yours exactly if that's what you did. And then here I'm going to say assign values to our 2D array. Now you know what, since we made these random, since we made this random object, maybe we ought to go ahead and use it. So this place where you calculate the value for each element in the two-dimensional array, let's change it a little bit to use our random number generator. Let's just use next double. So, comment that out. Array2 r comma c inside the square braces is equal to r&d dot, except these are ints, so I'm just going to say next. And if I don't specify an upper value, it's going to be fine. But I am going to specify an upper value. If I make it 1000, it'll count from 0 to 999. That'll fit in 3 places, and since I think I formatted my print statement to be 4 spaces, that'll work okay. Why don't I put a little comment here, though, just to remind myself. Between 0 and 999. Not 4 nines, 3. Okay, so I've changed this loop to assign random values rather than assigning 0 times 0, 0 times 1, 0 times 2, and so on. And let's make sure it works. Well, what do you know? That's pretty large. Okay, anyways, here they are, right? There's our two-dimensional array full of random values. And here's where we're adding up all the numbers in that array, right? 496, 641, 130, and so on. And this is our running tally. And yeah, we could calculate the average or something like that at the end of it. All right. So, assign values to our 2D array, that's the code for that. Printing our 2D array, that's the code for that. These are kind of things that I could ask on an exam or something. And then printing out a one-dimensional array with for each. That's that. Summing the values in a multi-dimensional array or a single-dimensional array, any kind of array. The same syntax would work. As long as it was numbers, right? If this is full of doubles, we wouldn't want to be adding them to an int, right? Maybe we change this to a double just for funsies. Why do that? Just because it would allow us to later change this to, an array of doubles or whatever. We wouldn't even have to change our summation code. All right, is that about enough about 2D arrays? I think it about is. I want to broach the idea of parallel arrays one more time. So I'm just going to make two arrays. One is going to be an array of pet names, and then the other is going to be the type of food we give them. So, string, like that, string animals is equal to new string, and we need room for 3 strings because we're going to have 3 animals. And so let's make animals subscript 0 equal to Pooch the dog. Animals subscript 1, whoops, equal to Felix the cat. And animals subscript 2 is equal to Clucky the chicken. Now we're going to make a parallel array. It's also going to be 3 elements, right? Because parallel arrays are 2 or more arrays of the same length where the elements are thematically united by their subscripts. So, string feed or foods or whatever is equal to new string subscript 3. Feed subscript 0. Well, what does our dog like? He likes steak. He's a very spoiled dog. Feed subscript 1. What does our cat eat? He eats birds. And then feed 2. Our chicken's going to eat corn. And now we could print out a table of animals versus their favorite food. So we're going to use a loop to do so, but I'm not going to use a for each loop. Why? Because I need an index number to tie these 2 things together. So whenever you're processing parallel arrays, you're probably going to do it by index number. So for int I love I as my index value, equals 0, I is less than the length. You know, I could just make it 3 because I happen to know 3. Oh, I see a change I want to make there. But anyways, instead I'm going to use an array name. Animals.getLength. I++. Why are you giving me grief there? Alright, it's just length if it's a one-dimensional array. And it's not a function, so I'm leaving off the parentheses. Alright, I have an index counter, so I can use that to print out, 2 values. Console.writeLine animals subscript 0 in subscript plus quote eats. Let's put some spaces around the word eats. End quote plus feed subscript. And why did I make a subscript 0? That means that Pooch is going to eat all the steak, birds, and corn. That's kind of greedy. So let's fix that. This should be animal subscript I, right? Because that's the index. You don't have to space it out like I did, and it'll probably correct it as soon as I hit enter anyways. But that's our index, right? So that animals 0 matches up to feed 0. Animals 1 matches up with feed 1, and so on. And let's try it out. And oh dear, have I had it pause the whole time? Nope, we're still going. Alrighty. And so Pooch eats steak, Felix eats birds, and Clucky eats corn. I think I knew as a kid somebody who actually named his dog Pooch. I like that. Guess that's better than calling it dog. So here's our loop for printing out the parallel array. Go ahead and pause if you need any of this. I'm going to scroll back up and show folks where we added the random number generator. So way up here, inside the place where we were creating our 2D array, so right after the random R&D is equal to new random, we commented out that line and we added this line to it. And then back down to the bottom. So did I have to do it like this? Did I have to assign the 3 values like that? I could have just used an initializer list. When I was creating this array, I didn't have to hard code it to 3. I could have used animals.length there, which would be more correct because I would want it to match exactly the length of this list. Now they do happen to match because I set them equal to a constant there. I may make that change while I'm looking at it though. Animals.length. Right. Just to make sure that these are parallel arrays, that they are exactly the same length.
I guess it don't always pay to just cut and paste all the time. You gotta at least look at that.
Yeah. Okay. So just for grins, I want to remind you that you can print an array without using a loop. Now, on an exam, if I ask you to print an array using a loop, you better not do it this way. But just for debug purposes, you could do this. Console.writeLine array dot. Well, that didn't work. Okay, I botched it. Un momento. All right, let's take one more stab at it. So, console.writeLine animals.toString. That gonna work? Let's see if that works. And if it doesn't, I'm not going to spend any more time on it. No, that did not work. Alrighty. So I could use array.toDelimited string in order to do that, as I see by looking over here. So I'm going to take this and I'm going to say array or animals.to. In fact, as a matter of fact, I'm going to forget it. Never mind. All right. So that's our accepted way of printing out an array, right? These are little for loops. For each is the best. An index-based loop is also a perfectly acceptable way of printing out an array. All right, I think we've done enough for today. A couple of more things I want to mention today. We have some project ideas for you. If you've taken my other courses, some of these project ideas may be similar. I would rather you do another project than what you've done in the past, if that is the case. And they go from simple to complex in my project ideas document. But let's go take a look. Put myself into student mode. Scroll down to the projects folder. Project ideas. Now this is a big document just because I haven't split them up like into 5 different project folders, 5 different project files or whatever. I may do that to make it look less intimidating. But anyways, Caesar cipher. Write a program that will implement a Caesar cipher. In Java, no, this is in C#. So why don't I just delete that little phrase there? Because you better do it in C#. This is a C# class. So it should ask for input and a value to shift by. It will then output that input where every character has been shifted by that value. So for example, if you type in I love my ABCs, why don't I zoom in? And then I say shift by -1, and that is the completely wrong output. Yep. What it's supposed to do is what's 1 less than I? H. What's 1 less than L? I don't even remember, for Pete's sake. Hij. 1 less than O is N. 1 less than V is U. 1 less than E is D. 1 less than M is L. 1 less than Y is X. 1 less than A, well, we got to wrap around, right? Because 1 less than A is what? So Z. 1 less than B is A. 1 less than C is B. And 1 less than S is R. So I may have done that wrong. I will double check it. But there we go. That is this value shifted by -1. And if we were going to shift it by +1, right, it would go the other way. I would become J, L's would become M's, M's would become N's, Y would become Z's, and so on. And so if you get to past a Z, when you're shifting by a positive number, you got to wrap around back to the beginning. So I wrote just a very simple one that only shifted uppercase letters, and it skipped everything that wasn't an uppercase letter, so it maintained the spaces. That's a simple one. You could also do one that did ASCII values over the entire range of printable ASCII characters, right, from the space bar all the way to lowercase z and some other punctuation. So, you know, if it gets to 127, you wrap it around to 32. If it gets below 32, you wrap it around back to 126. So if you get stuck on the formulas for this, I could give you some help on that. Once you're done with this, modify your program so that they can enter a lower and an upper value, right? So instead of just saying -1 and it printing out one answer, you know, they say -10 to +10, and it and it shifts at all those different times. So here's our input. Any zebra, what is our lowest to shift? -5. What is our largest to shift? 5. And so shifting -5, -4, -3, -1, right? If you shift something 0, it's just the original phrase, right? Because you're not moving it either up or down. And here we can see that the A's become B's if you shift it once. If you shift it twice, an A becomes a C. And if you shift it 5 times, an A becomes an F, and so on. And if you shift it -1, an A becomes a Z, right? It's wrapped around at the end of the alphabet. A becomes Y if you shift it -2, and so on. Okay, so I consider that a pretty simple one, especially since I just offered to give you help with the formulas. All right. The next one, exclusive OR transformations. Well, what is exclusive OR? I don't recall if I told you what exclusive OR is, but if you take a bit and you exclusive OR against another bit, it follows kind of the logic of an OR, right? Our OR logic looks like this. 0 and a 0, if you OR them together, you get a 0. 0 or 1, OR them together is 1, because OR means one or the other has to be lit. But if they're both lit, great. Y'all, so much the better, right? So that's the truth table for OR. Now exclusive OR works like this. Same truth table, but there's one key difference. Only one value can be set to 1 for the result to be 1. If they are both the same, if they're either 0s or 1s, then the result is 0. So 0 exclusive OR 0 is equal to 0. 0 exclusive OR 1, well, one of them is a 1, so that's good. 1 exclusive OR 0, that's also a 1 because one of them is set to 1. Oops, 2 of them are set to 1, but we need them to be exclusive, 1 and only 1, so that's back to 0. So that's a truth table for exclusive OR. Now the exclusive OR operators, well, we haven't even done bitwise operators, I don't think. I might need to do another lecture on that, but you can also You can also Google bitwise operator in C#, and we will see that a single ampersand does a bitwise AND, a single bar does a bitwise OR, and a caret, a shift 6, does a bitwise, exclusive OR. So I'm going to go back to my output and just exclusive OR some things, right? So if I do this, int x is equal to 1 and 2, whatever, right? It follows the rules of ANDs. Int y is equal to 1 or 2, that does a bitwise OR. Int z is equal to 1 exclusive OR 2, that follows the rules of exclusive ORs. Tell you what, I'm going to do 2 and 3, 2 and 3, 2 and 3 in my little example in the notes. All right, so if we're going to do 2 and 3, bitwise, a 2 looks like this. Bitwise, a 3 looks like this. So if we're going to OR those guys together, or wait, let's do AND first. Then the only time that they are 1s is when both of them are 1s. So if we figured it out, a 0 and a 0 is a 0. A 0 and a 0 is a 0 in the second column. A 1 and a 1, okay, there's our magic moment. And then a 0 and a 1 is a 0 because those were ANDs. I'm going to do the same thing for ORs. That means one or the other. 0 or 0, well, that's still a 0. 0 or 0, well, that column's also 0. 1 or 1, well, that's a 1. 0 or 1, well, that's a 1. All right, so that's the result of a bitwise OR between 2 and 3. Maybe I better put, like that. And now we're going to do exclusive OR. So that's a 2, that's a 3, but we're going to do exclusive OR, which is the caret, the shift 6. Now 1 and only 1 can be set for the result to be a 1. If it's 2 zeros or it's 2 1s, it's going to be a 0. So 0 exclusive OR 0, 0, because there's not one bit set. And again, 0 or 0 is 0. 1 exclusive OR 1, well, we don't have 1 and only 1 set. We have 2 sets, so that's a 0. And that's a 1. So that is our result of an exclusive OR. So that wound up being a 2. This wound up being a 3. This wound up being a 1. And if I print those values out, console.writeLine, let's put in 3 placeholders. 0, 1, 2. And we're going to fill them up with X, Y, and Z. Hopefully it'll print out the same thing that I just wrote down on my notepad. If not, my faith in the universe is broken. All right, 2, 3, 1. Here we go, 2, 3, 1. Right? So that's exclusive OR, right? All you have to do is use that value. All right, let's go back to the projects. All right, so ask them for a line of input. Each line of output will be a series of bytes. You'll make an array of bytes. So line 1, I guess you don't have to make an array, but it'll certainly be a lot easier in my mind if you do it that way. Line 1 is the ASCII values of the input. You just cast from from characters to ints. So you can make an array of ints. Line 2 is the original values exclusive ORed with 1, 1, 1. And then line 3 is the results of line 2, again exclusive ORed with 1, 1, 1. So you'll get your original if you do that. If you exclusive OR it once, then you get something, and then if you exclusive OR that something, then you'll get your original value. And then we do that again. We exclusive OR, but instead of just always doing it with 1, 1, 1, we do it with sequential values starting with 0. So the first one we exclusive OR with 0, the second one with 1, the third one with 2, and so on. And in line 5, we take the output of line 4 and do that same thing again. We exclusive OR it with sequential values. So when I wrote the program, it looked like this. What is your input? ABC hello. So we printed out the input. We printed out the ASCII bytes of that. We just cast each one to an int. And then we started playing. Here we we exclusive ORed 65 with 1, 1, 1, and we got that. We exclusive ORed 66 with that. Now I'm not going to go in a notebook and show you that that's true. Notepad. 101 exclusive ORed with 1, 1, 1 is 101, and so on. And then we did the same. We exclusive ORed them against that value again, and we got our original values. That's just a double check to make sure it worked. And here we exclusive ORed sequentially, right? So that was exclusive ORed with 0. This one is exclusive ORed with 1. This one was that one exclusive ORed with 2, and so on. And then we did the same exact thing to verify our results. And then we printed out the string of the last results. We just cast each int back to a character so we could print it out. All right. All right. Now they're getting a little bit harder in my mind. Write a program that lets the user play Hangman. You know how to play Hangman. I'm not going to spend a lot of time lecturing it. Let's play Hangman. I'm thinking of a word. It's 7 letters long. You have 8 mistakes. Okay, so guess a letter A. Woohoo, we got it right. Now guess what? Our magic word actually is hangman in this case. So, yeah, a sneak preview. Guess a letter B. Well, B is not in our word. So incorrect. You can only make 7 more mistakes. C. Nope, that's wrong. 6 more mistakes. Now we're not going to draw a picture of a dead guy hanging from a noose. Guess a letter G. Aha, there is a G. Guess N. Woohoo, now we're getting the idea. Hangman. Now apparently we've had a little brain seizure and we guess D. So there's no D's in there. We have 5 mistakes. We guess an E. There's only 4 mistakes left. We guess H. It says hangman. And now we get a brilliant idea. Maybe it's hangman. And so we stick an M there. It fills it in and it says you won. Play again. YN. Okay, done. All right. Now this one's a really long description. So I'm not going to even go over it. But maybe as a kid you played the game Mastermind that looked like this, where one player set up some hidden little code based on colored pegs, and then you tried to guess them, and based on how many of the numbers you got right, how many of the pegs you got in the right position, you were awarded blacks, and if you had the right number but they were in the wrong position, you were awarded whites, and you use that information to get the exact match. Right, except we're not going to use colors, we're going to use numbers, right? You might use 1, 2, 3, and 4 because it looks like we have 4 different colors here. And here's my sample, you know, of what the output might look like. You know, 555. Our guess was 555. Nope, we didn't get the right guess, but we do have 1 correct. So we know that there's a 5 in it somewhere. And eventually we guessed 111. We didn't get any correct, and none of them were misplaced, so we're flat out sure that there's no 1s in it, and so on. So just scroll through this, read the instructions for Mastermind, watch the video that I linked to if you feel like implementing it. All right, and then the Hungry Monster array. Hungry Monster, what you do is you create an array, you fill it with some random values, and then you have an asterisk that moves towards the highest value, and then it moves to the next highest value, and then it moves to the next highest value, and then it moves to the next highest value, and so on until it is all zeros, in which case, you know, the monster doesn't have any more to eat. So if I was going to reprint this array, I would just use dots instead of zeros to make it easy to print out, right? I might use if statements or something like that. If the value is 0, print out a dot, otherwise print out that 3. It's a 2-dimensional array. So, in real life, I want you to make a 40 by 40 array, but of course I didn't make my example that big, right? And so here's an example of what it looks like. The monster starts off at position 0, 0, and he starts heading towards the largest value. So it searches the array, it finds the position of the largest value, and the monster starts moving towards it with little, you know, left-right moves or up-down moves. He's getting closer to the 7, and he banks down, and you know, and however you decide to move it, you could decide, right? You know, is it just going to move all the way to the right column and then go to the, you know, right row, rather than kind of doing this diagonal thing? Whatever. He's almost at the highest value. He's getting closer. Finally, he eats the highest value. So it says monster ate the 7. Now it's got to find a new highest value. So it searches the array again. It spots that 6. And so on, until it goes down there and there are no highest values. They're all equal to 0, in which case you just, you know, print out the final array and you're done. This one's kind of challenging. If you like 2-dimensional arrays, or if you want to learn more about 2-dimensional arrays, that's not a bad one to do. Then one called P-Fighter. This is another long one, so I'm not going to explain it very well, but what you do is you enter the values for 2 fighters based on specific rules. Each fighter has a name, a combat rating, an armor rating. Why did I put armors? That should just be armor, huh? And then attack dice, right? And so CR is equal to the health of the fighter, like hit points if you're playing a game, right? And, you know, you're playing Street Fighter or whatever, and he has a health bar or whatever. Attack dice is how many dice the fighter gets to roll in an attack. And then armor is how many points of damage is absorbed. So what happens is each fighter rolls their attack dice. They compare each other. You take the difference between the two, and like if fighter 1 rolls a 10, then fighter 2 rolls a 7, then there's going to be 3 points of damage awarded. But then you check that guy's armor. And if that guy's armor is 3 or greater, then he didn't take any damage at all. You know, but if his armor is like 1 and he was supposed to take 3 damage, then 3 minus 1 is equal to 2. And so then again, we have a long demonstration of it, a long explanation of the logics. And then down here at the bottom, one thing I would like for you to do, maybe you don't do it, is create a history of them. So, you know, if this one lasted 5 rounds, then, you know, 1, 2, 3, 4, 5, 1, 2, 3, whoops, there's another mistake. So on the 5th round, you know, he ran out of hit points, just like the health bar in Street Fighter or whatever like that. And all the stuff up above it was showing what happened. So like Conan rolls 5 dice and has an armor of 1. So Conan rolled all that, plus his challenge rating bonus, gets that. Trogdor rolls that, plus his challenge rating bonus, and that. And so the difference between that and that is 3. So there's going to be damage awarded. Something's looking wrong there. 22 and 25, so it should be 24, 2 and 20, 25 and 22. So the damage should be 3. However, Conan's armor absorbs 2, so Conan is hit for 2 points. His challenge rating drops from 10 to 8. Hope that makes sense. Now, the only problem you could get if you implement this little game is if their armor is too tough, then the 2 fighters will sit there swinging at each other forever, right? Because they'll never land a hit. Their armor will absorb too much damage. So, I ask you to come up with some way of avoiding that, right? You can make it so that, you know, after a certain number of turns, their health starts going down because they're getting tired, or after a certain number of turns, their armor starts going down because their armor is taking a lot of hits and, you know, beginning to look really sloppy. Whatever. So some people like this one, especially if you're like into video games or Dungeons and Dragons or Pathfinder or whatever, then that kind of, you know, war games, that kind of makes sense to you. All right, that's it. If you don't like any of these, send me an idea for another one. Send me an idea for another one, and I'll probably okay it, right? If you make it too complex, then there's a very good chance you won't actually be able to get it done by the end of the semester. So, you know, I might take into an account that you picked too large of a one and give you credit even, you know, for the work you get done. But I'd rather you actually choose a task that you're pretty sure you can get done. That's why I want you to send it to me. All right, hope that makes sense. Come up with your own project idea, pick one of these. I'll probably separate them into separate documents so it's really easy to figure it out, because otherwise this is like 16 pages of madness, right? So, kind of intimidating. This one is my assumption is the easiest one. So if you want to go for, you know, that, no shame in that, right? If you want to pick one that's, you know, a little bit more challenging, that's totally cool as well. All right, that makes sense. All righty. Guess we need to make a Dropbox. We also need to see if we had any homework assignments queued up to do next after that lecture. And Denise is going, I don't want you to do that. You can leave off the homework. And I can't leave off the homework. All right. So this homework is called Orcs versus Elves, and it uses arrays. So let's read the instructions for that very quickly. I think this is turning out to be a long lecture. Well, an hour and 4 minutes. Almost as long as a class if you're sitting in lecture. All right, so here's the way this works. Note that the program relies on random numbers. Just as a review, here's how you generate random numbers. Okay, assignment. Write a battle simulator that will fight an array of elves against an array of orcs. So you declare an array of 10 ints. You call that array orcs. You set their health equal to 20. Then you declare another array called elves. You also initialize their health equal to 20. And then each attack is decided by a roll. So you will need to generate random numbers between 1 and 6. So an attack consists of one elf fighting one orc. Each one rolls a die. Whoever rolls the higher wins. The loser deducts from their hit point the difference between the die rolls. So the first elf in the array will fight the corresponding first orc, like parallel arrays. When an elf HP is reduced to 0 or less, that elf is defeated. Same for orcs. So what I would do is I would have my array, I would allocate all the damage where each one fought something, and then I would resort them so that the highest values are up at the front, right? Your toughest orc goes and fights your toughest elf. And that way you don't have to worry about blanks in your arrays, right? You know, where the second elf has been defeated, what's the second orc going to do, so on. So here's my example of what it could look like, right? Hopefully that makes sense. The rules, the page looks actually, I mean the assignment looks actually longer than it is, right? Because I described too much. So don't be overwhelmed. And if you need additional explanation on it, I can help you with that. Basically, you're just generating two arrays. You're generating random numbers, and based on those random numbers, you're going to be reducing the value of either one array, one element in one array, or the same element in the other array. All right. I have talked too much. My voice is going to go. Let's stop. Make a Dropbox. We are in Lecture O.